So, like adding and subtracting, the very first step, write things as improper fractions. Here, when we have a whole number like 3, you can write that as a fraction. 3 over 1 times by 3 over 4. So we write them both as fractions. Then with fractions, you multiply the tops together, you multiply the bottoms. The proper names would be to multiply the numerators together and multiply the denominators together, but that's a lot more letters to write, so it takes longer in our notes. So when I multiply 3 times 3, I get 9, and 1 times 4 is 4. And that is our final answer. We would write it in lowest terms if we could, but multiplying is easier than adding and subtracting because you do not need a common denominator. So here's a second example that we'll do together. 16 times 1/3. First of all, how could I write 16 as a fraction? 16 over 1 times by 1 over 3. If you multiply the tops together, what is 16 times 1? 16. What is 1 times 3? Can you simplify that? No. You're looking, if you want to have this in lowest terms, there would have to be a number you could divide the top by, and the same number would have to divide the bottom. But you can't divide 16 by 3, which is the only thing that you can divide the bottom by. So this is in lowest terms. Two sevenths times 7/4. Ooh, I like this one. They're already both fractions, so you don't have to take an extra step to change it to improper fractions. You could write the last one as a mixed fraction, yes. So, since we're multiplying, we multiply the tops. 2 times 7 is 14. Good. And 7 times 4 is 28. Is that in lowest terms? What could you do? It does reduce to 1 over 2. Excellent. You could do 7 over 14 and then say, oh, I could divide them both by 7 and then eventually get to 1 over 2. So 1 over 2 is our answer. What I really like about this question is, would you guys agree that 2 times 7 is the same as 7 times 2?
Yes.
Yes? You've learned that? You've learned that before?
Yes.
So if I wrote these fractions and instead of on the top had 2 times 7, if I wrote it as 7 times 2, that wouldn't change anything, would it?
No.
Okay, so I'm going to keep the... This is still going to be 14 on the top, still 28 on the bottom, right? But what is 7 divided by 7? 1. And what happens when you multiply something by 1? It stays the same. So look at this. What's 1 times 2/4? 2/4. And that reduces to 1/2. Cool. One of the things as a shortcut for multiplying, you don't have to use this if you don't want to, but as a shortcut for multiplying, you can simplify a fraction early if you would like. And it's based on this idea that 2 times 7 is the same as 7 times 2, right? And you know that 7 divided by 7 is just 1. So when I look here and I see a 7 here and a 7 here, 7 divided by 7 is just 1, so I can just put 1s there instead. And 1 times 2 is 2, and 1 times 4 would be 4. And that gives me 2 over 4, which is 1/2. So for example, if I give you a hard one, who knows their 37 times table? Good. Good. Nobody does? Excellent. 5 over 37 times by 37 over 7 is equal to
5 over 7.
5 over 7. Excellent. How did you do that so fast? Right, because these ones would just be equal to 1. 37 divided by 37 is equal to 1. So you can simplify like that. That's a shortcut. You don't have to do that, but it is nice if you can.
That's the only way, but then it's just the other way. And you can't just do that with any number.
You can't do that. If they're the same, they can both be like this. You can also do it if we add an... Okay, none of the numbers are the same, but you can simplify fractions, like going diagonal. 3 over 15 is the same as what? 3 over 15 is the same as 1 over, close? 1 over 5. So you could change the 3 and the 15 to a 1 and a 5. 8 over 4 is the same as what over what? Close? Two over 1. So you could go over here and change this to a 2 and a 1. And then what's 2 times 1? And 5 times 1? 2/5. If you simplify it early, you don't have to reduce to lowest terms because you've done it early. If you don't see how that works, keep it the same as we had before. We originally had 8 over 15 times by 3 over 4. 8 times 3 is 24. 15 times 4 is 60. Then you have to reduce that fraction. You can see that you can divide both the top and the bottom by 2. That would change this to 12 over 30. I can still divide them by 2. That would change this to 6 over 15. Can I simplify that fraction by 2? No. Can I divide them both by 3? Yes, and then I would get 2 over 5, which is the same answer that we got by simplifying early. So that is some interesting things that happen with fractions if the fractions can be simplified. If you don't want to learn that shortcut, you can always do it by multiplying the tops, multiplying the bottoms, and then simplifying afterwards. But you see, when we simplify it afterwards, it sometimes takes a little bit longer, and you have to deal with bigger numbers. So if you like working with smaller numbers, simplifying early is nice, and you can simplify on the diagonal like we did here. 3 and 15 is the same as 1/5, so I changed that to 1/5. Okay, one for you to try on your own. Ooh, with a negative. Okay, first of all, we've got a negative. I'm going to put my negative just on the top there. Negative 7 over 3 times 6 over 5. If we multiply the top, 7 times 6 is? Negative 42. 3 times 5 is? 15. Now, it's the tricky part. You can divide them both by 3, and you'll get negative 14 over 5. That is in lowest terms. That's right. You could write it as a mixed number, negative 2 and 4/5 if you'd like, but there's our final answer. I also want to show you that if you started with negative 7 over 3 times 6 over 5, and you checked if any of your fractions, even on the diagonals, reduced. Because you can't reduce 7 over 3, and you can't reduce 6 over 5. But you can reduce 6 over 3. 6 over 3 is the same as 2 over 1. Not 1/2, 2 over 1. So I'm going to get rid of my 6 and 3 and rewrite it as 2 over 1.
How'd you get 14 for that one?
I divided by 3, and I divided by 3.
Oh, so you're supposed to divide.
Right? That's how we reduce something. You have to find a number that both of them divide by nicely. Now, look what happens if I reduce early. What is negative 7 times 2? Negative 14. And 1 times 5? If you reduce early, your answer will be reduced already. So some people like that reducing early because they deal with smaller numbers. The biggest number we got on the right side is 14, whereas over here we had to deal with 42. So some people like that if they can reduce early. Here's another one for you to try. I've got -5/4 times by -2/3. If I multiply the tops, -5 times -2 is +10. 4 times 3 is 12. Can I reduce this? Yes. I can divide both the top and bottom by 2, and I'll get 5/6. Awesome. If you wanted to simplify first, you would check inside the fractions. Can I simplify 5/4? No. Can I simplify 2/3? No. On the diagonals, can I simplify 5/3? No. But I can simplify 2/4. 2/4 is the same as 1/2. So if I get rid of this -2, I'd have -1. If I get rid of this 4, I'd have 2. Then if I multiply the tops, -5 times -1 is 5. 2 times 3 is 6. Another one to try. If, since we have fractions here, 8 times 3 would give us 24. 5 times 2 would give us 10. So if we just multiply the tops and multiply the bottoms, we get 24/10. This isn't reduced. In order to reduce it, you need to find, is there a number you can divide 24 by that you can also divide 10 by? What I like to do for reducing is I start by dividing by 2. Can you cut them both in half? Yes. I can divide this one by 2. I can divide this one by 2. If I divide the top one by 2, I'm going to get 12. I divide the bottom one by 2, I'm going to get 5. I don't know if I'm done, so I have to check what are numbers you can divide 5 by? Only 5, right? There's no other number you can divide 5 by. I mean, you can divide it by 2, but then you get a decimal. There's no other whole number you can divide 5 by and still get a whole number, except for 5 and 1. And dividing by 1 doesn't really help you because you get the same number again. So then you check the top. Can you divide 12 by 5 and get a nice whole number? No. So we're done. This is our final answer. That's how we know when it's in lowest terms. If we simplify first, 8/5 times by 3/2. We check our fractions. I can't simplify 8/5. I can't simplify 3/2. But on the diagonal, I have 8/2. And 8 divided by 2 is the same as? Close, 4/1. And if I did that, then I'm going to get rid of this 8 and replace it with a 4. Get rid of this 2 and replace it with a 1. And then I'll have 4 times 3, which is 12. 5 times 1, which is 5.